All right, 6.3 part 1 deals with logarithmic functions. So log functions are a new concept that we haven't done before, but it ties into exponential functions, and I'll show you how. So we know that 2 squared is equal to 4, and 2 to the third power is equal to 8. However, for what value of x does 2 to the power of x equal 6? We can find what this x value is here by using log functions. So log functions help us figure out what exponents give us some value. So we can take a log function and turn it into an exponential function, and we can turn an exponential function and turn it into a log. So we would read this as log base b of y is equal to x. So whatever our base is, that little number down there is always our base, and we read it as log base b of y. So we can change, for example, if we had log base 7 of 49 is equal to 2, we can change this to exponential function by keeping our base. So our base is 7. The base always is your base, so this is your base. We take what's on the right, move it to the left, what's on the left, move it to the right. So the 2 becomes our exponent, so this would be 7 squared is equal to 49. So this is in logarithmic form. This is exponential form. For example 1, we're just taking it from logarithmic form to exponential form. So all we're doing is rewriting our equation. So our base stays our base, the 4 goes on top, and the 16 goes to the right. So 2 to the power of 4 is equal to 16. For b, what's our base? 4. What would our exponent be? 0. And what's that equal to? 1. So 4 to the power of 0 is equal to 1. What about for c? What's our base? 12. What's our exponent? 1. And what's that equal to? 12. 12 to the power of 1 is equal to 12. And then d, what's our base? 1/4. What's our exponent? -1. And what's that equal to? 4. So all of these are true statements. We're just rewriting our log form into exponential form. So there's not really a lot of math going on right now, just rewriting it. Any questions? All right, the next example, we're taking it from exponential form and putting it into logarithmic form. So logarithmic form always has that word log in it. We always start with our log. Our base is our base. The 2 goes to the right, so what's on the left goes to the right, what's on the right goes to the left. So we would have log base 5 of 25 is equal to 2. So we just do the same thing we did before. So for b, we start with that word log. What's our base? 10. What comes next? 0.1. And then what's that equal to? -1. All right, c, what's our base?
8.
So log of 8, log base 8 of what? What comes next? 4. And what's that equal to? 2/3. Last one, D, log base what? What's our base? 6 of, look, 1 over 216. And then what's that equal to? -3. Any questions here? Alright, for the next example, example 3, we are evaluating our logarithmic expressions. Now when our expression has log in it, we don't know how to compute log. We can't figure that out in our head. Our head's not a calculator. But we can turn this into exponential form and figure it out. So we're trying to find what log base 4 of 64 is equal to. So we can say it's equal to x. We're trying to figure out what that x is. So how do we change this into exponential form? What's our base? 4. What's our exponent? X. And what's that equal to? 64. So 4 to what power gives us 64? Let's see. What's 4 times 4? 16. So this would be 4 to the second power. Not quite 64 yet. So let's multiply that times another 4. What's 16 times 4? 64. So how many 4s do we have? 3. So x is equal to 3. So always ask yourself, 4 to what power gives you 64? Any questions on that one? All right, let's take a look at B. So this is equal to something that we're trying to figure out. What's our base? 5. What's our exponent? X. And what's this equal to? 0.2. Now it's a little tricky because 5 to what power gives us this decimal. We're kind of more used to seeing it as a fraction. How do we change 0.2 to a fraction? What would 0.2 be in a fraction? Awesome. It would be 2 over 10, which simplifies to 1 over 5. Perfect. So 5 to the power of x is equal to 1 over 5. Now maybe we can see it a little bit clearer. 5 to what power gives us 1 over 5? -1. Perfect. Because when our exponent's negative, we flip it. Alright. So this is equal to something. What's our base? 1/5. What's our exponent? X. And what's this equal to? 125. So 1/5 to what power gives us 125? Do you think our exponent's going to be positive or negative? Negative, because we want to flip this to make it a whole number, not a fraction anymore. So our x is going to be equal to some negative number. 5 to what power gives us 125? 3. Because 5 times 5 is 25. Not quite to 125. Let's multiply it times another 5. So 25 times 5 gives us 125. So we need 3 5s. And then the negative is what flips that 1/5 to be a whole number. So x is equal to -3. What about D? What's our base? 36. What's our exponent? X. And what's this equal to? 6. So 36 to what power gives us 6? One half. Awesome. So it's not a negative because a negative would turn it into a fraction, but it does get smaller, so it can't be a whole number. because 1 would be too big, 2 would be too big, so we would have to start thinking fractions. Remember, the exponent of 1/2 is the same thing as taking the square root. So the square root of 36 is 6. So for these questions, you kind of have to think a little bit to figure out what power gives you that answer. So these require a bit of thinking. Any questions from this page? No questions? Alright, next page. So here it talks about our common logarithm, which is a logarithm with base 10. The common logarithm is the only logarithm we can put in our calculator. Your calculator automatically gives you a base 10, and you can't change it. Most calculators, you can't change it. Some of the newer fancy ones you can. But most of them, anytime you press the log, it just gives you log of what? And it just automatically assumes your base is 10. So calculators can only do the common logarithm, which if we have a common log, you don't even need to write that base 10. You could just write it as log of x. So when you write log of x, it's assumed that your base is 10 because you have a common log. A natural logarithm is when your log has a base e, which it's written as ln of x. So log base e is the same thing as ln of x. It's our natural log. ln is a different button in your calculator. So you can take the log of a number, or you could take the ln of a number. So both of them are just different buttons in our calculator. So example 4, all it's asking us to do is put it in our calculator. So what is the log of 8? Gotta use your calculator. .903. It just asks us for 3 decimal places, so we're good with that. And then what is the ln of 0.3? Negative 1.204. Let's round up.
Call me later, 2:30.
We have 12 examples here. I want you guys to spend the next 7 minutes working on this. So we'll go over it at 2:06. So what's our base here? 3. So we start with 3. 3. What's on the right goes to the left. What's on the left goes to the right. So what comes next? What's going to be our exponent? Dominic, what's our exponent?
4.
4. And then what's that equal to? What do we have left?
81.
81. So 3 to the 4th power is equal to 81.
Oh, okay.
All right, Santiago, what'd you get for number 2?
I got 7 over 1 is equal to 7.
So 7 to the 1st power. 7 to the 1st power is equal to 7. Perfect. Alexis, what'd you get for number 3? So our base is 14. So then what's on the right goes up top to the left. What's on the left goes to the right. So what comes next? What's our exponent?
Exponent 0. Exponent 0.
And then what's that equal to?
1.
1. See, that wasn't too bad. 14 to the power of 0 is equal to 1. Sabrina, what'd you get for number 4?
I got 1/2 to the power of -5 equals 32.
Awesome. 1/2 to the power of -5 is equal to 32. Thank you. Marcella, what'd you get for number 5?
Log, and then the 7, 49 equals 2.
Perfect. But we would read it as log base 7 of 49 is equal to 2. But yes, good job.
Okay.
Ariana, what'd you get for number 6? So turning it into log form, we start with the word log. Next comes our base. What's our base?
1.
So our base is the big number,
50.
50. And then what's on the right goes to the left. What's on the left goes to the right. So what comes next?
The 1.
The 1. And then what's that equal to?
0.
0. Good job. Now do you get it? A little bit?
Yes.
Okay, awesome. That's why we're doing this. Ethan, what'd you get for number 7?
Log 4 to the 1/4 equals -1.
So log base 4 of 1/4 is equal to -1. Perfect. Julia, what'd you get for number 8?
Log 4 to the 1/4 power. Okay, log of 4 of 1/4 equals -1.
Number 8.
Oh, that's the wrong question, sorry. 256. I did it wrong.
What comes next?
Okay,
So
it's
you were right
log
so far.
256
Mm-hmm.
of 2 equals 1/8.
Awesome. Perfect. Who's next? Haley. What's number 9?
5.
Perfect. X is equal to 5. Bella, what'd you get for number 10?
3.
Awesome. X is equal to 1/3. Heaven, what'd you get for number 11?
0.07918124.6.
Okay, we're good with just 3 decimals. 1.079. Awesome. And then Anthony, what'd you get for number 12?
0.287.
-0.287, but it's 7.6, so it rounds up to 8.8. But awesome. Good job. Thank you for those that participated. Any questions on 1 through 12? Hopefully for those that did not understand, you are paying attention now, so maybe it makes a little bit more sense because this is one of the easier things that we're going to be doing for chapter 6.